In a previous video, I discussed how focusing on feature engineering based on scientific knowledge of the process that you're trying to model can be used to significantly improve the accuracy and performance of your ML model for your AIoT application. In this video, I want to go into a little more detail, so let's have a look at an example of a project that we recently completed for human fall detection for a smartwatch just using acceleration data. In a nutshell, the challenge for fall detection systems is discriminating between normal everyday activities and falls. So let's have a look at some data. Looking at the net acceleration data of typical everyday activities, such as someone brushing their teeth or doing some morning exercises, we see the following. Now let's look at some data for a fall event. As seen, it's not really easy to distinguish between the two. Therefore, we need to apply some physics to the process that we're trying to model in order to derive specific features from the sensor data so that we can make a classification. That is it a fall or not? This is best analysed by breaking the fall up into phases. Studying the diagram, we see that there are actually 4 phases from where the person is standing through to the point of where they're lying on the ground. So the big question is, how do we go about modelling these phases using accelerometer data? Well, looking at the falling event, we know that when a human falls, their centre of gravity changes as the body and muscles adjust the limbs and torso. This manifests itself as decreasing net acceleration for about 100 milliseconds or so. We also know that when a subject impacts with the floor, there'll be a large shock pulse with an amplitude of several G for a short period. And finally, after impact with the floor, there'll be a period of inactivity and the net acceleration will be constant and equal to about 1 G. Armed with this knowledge, we could now use feature engineering to design our features. A block diagram of the 4 derived features in the ML classifier that we developed is shown here. A key concept that we use for deriving the impact and motion indices is based around the analysis of the jerk pattern. The name's hilarious. Whereby the jerk pattern is obtained by numerically differentiating the net acceleration data. We can then apply the jerk pattern to qualify the aforementioned criteria for determining whether the data pertains to a fall or not. Notice that in all cases these features need to be cleaned in order to remove any measurement noise, glitches, filter setting ripple, etc. in order to make them high quality features suitable for the ML model. So armed with these cleaned high accuracy features, we can train our ML classification model. A key point here is that we only require a few high quality features, thus simplifying the implementation. Well, I hope that this has given you some more insight into the exciting world of feature engineering and why it's so important for producing high quality performance for AIoT systems. Leave your comments in the section below and let me know what your experience has been. Cheers, and I'll see you next time.